Hi. So in the previous section, we have discussed about the introduction of number system and different categories of number system like positional number system, non-positional number system, and why it is known as positional and non-positional number system. Today we will start with different types of number system. The first one is the decimal number system. So why it is known as decimal number system? Because deca means 10. So it is evident that there will be 10 different digits or the numbers to represent this decimal number system. And as we all know that there are 10 different symbols or digits, that is starting from 0 to 9 in decimal number system. And so what will be the base of the radix? So base of the radix will be 10, as there are 10 different digits or symbols to represent this number system. Now let's take an example of any decimal numbers, and here we will try to find out the position, how we can calculate the weightage, and what will be the positional value. See, so the first example is 2512. So we just need to represent in an array-like format. So if you don't know about the array-like format, I'm just explaining you. So take this number 2512, there is a fraction and there are fractional part as well. So just write these numbers in this way: 2, 5, 1, 2. You should write in this way because you need to allocate the position. Now we have fractional part 1, 9, 7, 1. So this is the integer part, this is the fractional part. So this will be, denote this one as decimal point. Okay. So how can you allocate the position? So the left side of the decimal point, you should start allocating the position as 0, starting from 0 and onwards. So it will be 0, it will be 1, it will be 2, it will be 3. As there are no more numbers, so we should stop at 3. And in the right part, there is a fractional part. You should start from negative integers. That is -1, -2, -3 and -4. Now, so this is the position I have allocated to this. Now what will be the positional value? And then comes the weightage. So we all know that in the positional number system, the positions, the weightage and the positional value, these are all interlinked. So positional value, so we all know the position 0, 1, 2, 3, -1, -2, -3. So positional value will be base to the power of position. And what will be the weightage? Weightage will be digit into positional value. So, and the decimal representation will be sum of the weightage. Now just let's take this example. So what will the positional value for this position? It will be base is 10 and position is 3, 10 to the power 2. What will be the weightage? Digit into positional value. So weightage will be 2 into 10 to the power of 3. In the same way, for the next one, the weightage will be 5 into 10 square. In the same way, so what will the weightage for this one? 1 into 10 to the power of 1. For this one, 2 into 10 to the power of 0. Okay. For the fractional part, it will be 1 into 10 to the power of -1. For the next one, it will be 9 into 10 to the power of -2 plus 7 into 10 to the power of -3 plus 1 into 10 to the power of -4. If you sum it up, it will again become 2512.1971. So the decimal representation will be the weightage of the sum of the weightage of each individual digit. And what is the weightage? Digit into positional value. What is positional value? Base to the power of position. So you can just take a note of this, because this is very essential while you want to convert any number system into the decimal, from any number system to decimal number system. So we have already discussed about the decimal number system. Now we will discuss about the binary number system. Now, as we all know that the term binary stands for 2. So it is evident that there will be two numbers. And what are the numbers? Those are 0 and 1. So using this 0 and 1, you can represent the entire numbers. I mean, entire set of numbers, whatever. Now, why this? So it is also a positional number system, because here the position also matters, because here the position matters, and there will be positional value and weightages. And likewise, we have in decimal number systems here also, as there are two numbers. So what will be the base of the radix? The base of the radix will be 2. Fine. And why this binary number is so essential? Binary number is essential in terms of digital system is because of that it has only two numbers. Now, if you want to design a digital system, and if we if you just relying on the decimal number system, so you have to design 10 different kind of voltages, because it has 10 different numbers. Now, instead of that, if you have a number system which is having just two numbers, 0 and 1, so that actually minimizes your scope, yet you can entirely represent your systems just by using two different kind of voltages, high and low. So that's why the binary number system is so important. But that doesn't mean computer system doesn't uses any other number system. It uses, but binary numbers plays a greater role in that. So let's start with an example. This is a binary number. It has only zeros and 0 and 1, and I have represented a number like this. Now, if you just want to find out its decimal equivalent, the conversion we will learn later. But how can you convert a decimal number to binary to decimal? But for the time being, we should concentrate on to finding out the decimal equivalent, because from this implementation, you can you will be able to learn the positions, how the positional value, how can you calculate the weightage, and etc. So this we need to also represent this in array like format. So let's write it down 1 0 1 0. Just 0 1 0 1. The convention is same. I mean, as far as allocation of the position is concerned, the convention is same. So likewise, we have this decimal point. This is also known as binary point. This is the fractional part. This is the integer part. Now, for the fractional part, you should start allocating numbers from -1, -1, -2, -3, and -4. For this one, you should start allocating position from 0, 1, 2, 3. So, you already learned about how to calculate the positional value. So, what will be the base of the radix for this binary system? That is 2. So, the positional value will be 2 to the power of 3. Here the positional value is 2 to the power of 4. So if the positional value is 2 to the power of 3, and here the positional value is 2 to the power of -4, so it is evident that these values or these positions carries the highest weightage, and this position carries the lowest weightage, and that's why it is known as most significant bit. And as it carries the lowest weightage, this is known as the least significant bit. And let's try to find out the decimal equivalent of this. And we're all aware of that. So the decimal equivalent will be the sum of the weightage. And you all know how to calculate the weightage. If you don't know, just look at my previous video. So for this one, so digit is 1, into base is 2, and position is 3. So 1 into 2 to the power of 3, this is its weightage. Here also, what will be the weightage? It will be 0 into base is 2, position is 2. Next, 1 into base 2 to the power of 1 plus 0 into 2 to the power of 0 plus 0 into 2 to the power of -1 plus 1 into 2 to the power of -2 plus 0 into 2 to the power of minus 3 plus 1 into 2 to the power of minus 4. This is the positional value, this is the digit, 1 into 2 to the power 3 is the weightage, and if you sum it up, it will become 10.3125 in decimal. So I hope you got the idea about the weightage, the positional value, and how can you calculate the decimal equivalent using this.